Good morning, students. I welcome you all for another lecture on the course Computer Architecture and Organization. In today's class, I am going to discuss about another important topic from memory systems, that was secondary storage. So basically, these secondary storage devices we can also call as external memories or auxiliary memories. So these memories, their capacity is very large as well as their cost is very low. That means cost per bit is low. In today's class, I am going to discuss about magnetic hard disk, which comes under this secondary storage memory elements. Right, we straight away discuss the concept. The main limitation of semiconductor memories, that means RAMs and ROMs, is cost per bit. That means the cost of semiconductor memories is very high. The reason for this is these semiconductor memories are operated at faster rates. Once the memory elements are operated at a faster rate, there is no doubt the cost per bit of the such memory elements are very high, so that the limitation of semiconductor memories was cost per bit. But what we are looking for in our computer systems, that is, large storage requirements of most computer systems are economically realized in the form of magnetic disk and magnetic tapes. That means sometimes we are expecting that our computer system must have large amount of storage elements, a large amount of memory elements within economic cost. From that point of view, we took the help of either magnetic disk as well as magnetic tapes. Generally, this magnetic disk and magnetics comes under the secondary storage devices, which we can also call as auxiliary memory elements or external memory elements. Right. So, magnetic hard disk. In this class, I was only focusing on the magnetic hard disk. In the next upcoming classes, we are discussing about floppy disk and CDs, DVDs, magnetic tapes. Those things we are discussing in upcoming classes. Right, in this class, I was only focusing on magnetic hard disk. The storage medium in a magnetic disk system consists of one or more disks mounted on a common spindle. What this is? It is a storage medium in a magnetic disk system. Magnetic disk system, I am not talking about magnetic disk. It is a magnetic disk system consists of one or more number of disks mounted on a common spindle. That means if you consider this a disk system, which may consist of either single disk or multiple disks which are mounted on a single spindle. So if you go for a diagram, then you have a better idea regarding to this particular statement. That means your hard disk may not be consist only one disk. If you consider your disk system, it may consist only one disk as well as multiple disks. A thin magnetic film is deposited on each disk, usually on both sides. If you took your disk system, on that we are giving a thin magnetized coating, which we are giving that coating not only a single side, we are giving that coating on both the sides of your disk. If you are giving a coating for both the sides of a disk, what happens is that particular disk can hold a large amount of information compared to a disk which was coated on only one side. So generally we are giving magnetizing coating for a disk on both the sides in order to increase the storage capacity of that corresponding disk. The disks are placed in a rotary drive so that the magnetizer surfaces moves in close proximity to read-write end. So what's the meaning of this? Once you insert our disk in a disk drive, then what happens is the magnetized surfaces of a disk which are moved or rotated, which is nearer to that read-write head. That means beneath of your read-write head, your disk was rotating like this. So the side which was faced your read-write head, that was side we have a magnetized coating. That means on that side we have to go and copy the information. So that the meaning of this one is the disks are placed in rotary drive so that the magnetizer surfaces moves in close proximity to read-write heads. Yes. So see here guys. So this is your spindle. That means here I was inserting here 3 number of disks. This is a simple spindle. On this I was inserting 3 disks. This is a rotating shaft, and these things we consider as heads. That means if you are assuming that our disk is coated with a magnetizing material on both the surfaces, that means on this surface we have a magnetizing coating, and as well as in this surface also we have magnetizing coating. If you have a magnetizing coating was present on both the sides, know that we have to go on to copy information on both sides of this disk. If I want to read or write something onto the surfaces of this magnetic disk, we took the help of these heads. These heads what I can call is read-write head. That means with the help of same head I can do both a read operation as well as a write operation. So all these heads are placed on in a disk drive. This whole thing is exists on your disk drive itself. I hope you understand. Like this we are incorporating a disk, and the head mechanism are placed like this. And here one more important thing is this head may be a mobile head or sometimes it is a fixed head. That is, it depends on a disk drive. Your head is mobile disk. That means that the head may move on any track over this disk itself. That means on the surface our head can go to any place over the surface of a disk. Such head what we can call is movable head. And we have one more variety of head is that is a fixed head. In that case, number of heads are fixed on a single plane. So each head belongs to one particular track which is dedicated on your surface of your magnetic disk. So here there are 2 varieties of disk systems we are using. In those disk systems we have to go and use 2 different types of head mechanisms. One is a fixed head mechanism and second one is mobile head mechanism. Right. Digital information can be stored on the magnetic field by applying of current pulses of suitable polarity to the magnetizing coil. Here what is magnetizing coil? Generally this magnetizing coil is nothing but your head itself. Just you can assume like that. That means if I want to do either read information, if I want to store, here my function is stored in the sense if I want to do a write operation. The digital information can be written on the magnetic film. The magnetic film where it is exists on the surface of your disk itself. So the digital information can be stored on the magnetic film by applying of current pulses of a suitable polarity to the magnetizing of coil. That means based on what all the information if you want to copy on the surface of your disk, we have to apply the current pulses to the magnetizing coil. That means your head itself. So based on the current pulses what we are sending through your magnetizing coil, automatically the information can be stored on the surface of your disk itself. So that's the meaning of that. The same head can be used for reading the stored information. That's what I am saying. Whatever the head we are using to do a write operation, the same head if you are using to read already stored information from the surface of a disk, no doubt such head is called as read/write head. Generally maximum disk system have only one head. That head can do both a read operation as well as a write operation. That is an economic thing that was exist in our disk systems. Fine. The disk system consists of 3 key parts. Your disk system consists of 3 key parts. One part is a disk. One part is nothing but disk. What is the assembly of a disk platters? That means this is These are the disk platters. So assembly of a disk platters here we consider as a disk itself. The assembly of a disk platters we consider as a disk. This is the first part in your disk system. And coming to the second one, disk drive. It is an electromechanical mechanism that spins the disk and moves the read-write heads. That means, in order to read or write the information what was present on the surface of a disk, what here we have to do in your disk system is, we took the help of a disk drive. In that, it is an electromechanical mechanism. In that, your disks are rotating beneath of your head. This head can move anywhere over the surface of your disk itself. So here the second part is a disk drive. It is the electromechanical mechanism that spins, that means that rotates the disk and moves the read-write heads over the surface of your disk itself. So that is the second part. And third part is a disk controller. What it is? It is an electronic circuitry that controls the operation of your system itself. What is a disk controller? It is a controlling circuitry which controls the operation of your disk system. That means if I want to do a read or write, in order to control that read-write operations, in order to control the movement of head, we need this disk control mechanism. It is an electronic circuitry that controls the operation of your disk system. So these are the three different parts that exist in your disk system. One is a disk, and second one is a disk drive, and third one is a disk controller. So the combination of these three things we consider as a disk system. Fine. Next one. Each surface is divided into number of concentric circles. Those are called as tracks. That means if you consider a magnetic disk, so on this surface of magnetic disk we have number of concentric circles. That means, let you can assume friends, this is your disk itself. So on this disk we have number of concentric circles like this. These are concentric circles. What we can call is, these we can call as tracks. These what we can call is tracks. That is the first thing you have to remember. And coming to the second thing, again each track can be divided into number of partitions. Those are called as sectors. That means if you consider this track I divided into number of partitions like this, number of partitions like this. These are partitions. What I can call is, I can call these are my sectors. So these are the sectors, but these are my tracks. And here important thing is, there was a gap that exists between two successive or consecutive sectors, as well as there was a gap that exists between two consecutive or successive tracks. So that we'll discuss next. The sets of corresponding tracks on all surfaces of disk form a logical cylinder. See here friends, this is your disk. On this I have concentric circles. These are concentric circles. What I can call is, this is my track, and this is my track, and this is my track. All these things we consider as a tracks. And again each track can be divided into number of partitions. Those are partitions we can call as sectors. This is one sector, this is another sector, this is another sector, this is another sector. Like this, your magnetic surface can be divided into number of tracks first. Later each track can be divided into small partitions. Those partitions what we can call is sectors. And here one more word we are using, that was a logical cylinder. That means if you remember this is in your mind, I can go to the previous diagram, that is I shifted to here. So all these are my disks. In this disk the same type of structure that was exist. What we are seeing just now. So in all of disk have concentric circles, those we can call as our tracks. Those again divided into small partitions, those we consider as sectors. If I consider this disk and this disk and this disk, a portion of sectors a portion of sectors of all these six forms looks like a logical cylinder. So that's what we are mentioning here. A set of corresponding tracks on all surfaces of disk forms a logical cylinder. So that you have to keep in your mind. The data are accessed by specifying the surface number, track number, and then sector number. That means in order to access the information from your disk system, then what we have to do is, we have to mention the surface number, as well as we have to mention a track number, as well as we have to mention that is sector number. For example, I have a 3 disk. I can give the surface numbering like this. This is surface 1, surface 2, surface 3, surface 4, surface 5, and then surface 6. For example, if I want to access the information from, I can give a disk numbering also. This is the first disk, this is second disk, and this is third disk. Right? So, in order to access an information from this corresponding disk, I need not be given disk number. I can straight away go and give the surface number, because the surface number was unique. For the first disk, I have 2 surfaces. One is surface 1 and surface 2. If I go for disk number 2, again I have 2 surfaces, but I have assigned the surface number is 3 and 4. If I go for a disk number 3, again it has 2 surfaces. I give a surface number like 5 and 6. In order to access an information from any particular disk, what I have to do is, I have to give surface number first, surface number, I have to mention this. For example, I would like to access an information from surface number 3. Then straight away I can go for disk number 2. Because disk number 2 itself only I have get a surface number 3. So here I need a surface number 3. Then on the surface I have number of tracks are exist. So I have to mention, I'm going to access my information from which track over that surface. So I can give a track number. So for example, my track number is some 10. Track number is 10. I have some 20 tracks are exist. Just you can assume every surface have a 20 tracks. Out of 20 tracks, I would like to access my information from a track number 10. On the track again I have some good number of sectors. For example, you can assume friends, each and every track can be divided into some 10 sectors. So here my aim is, I would like to access the information from sector number 6. So I must mention sector number. Sector number what it is 6. That means if I want access some information from any location of my disk, what I have to do is, I have to mention what is the surface number, as well as what is the track number, and then what is the sector number. If I mention these 3, then only I can go and access the information from a disk. So that you have to keep in your mind. Next, to distinguish 2 consecutive tracks, there is a small gap was exist between 2 tracks. That gap what we can call is inter-track gap. So I can give a more clarity by drawing this small diagram. So this is my disk. Let you gonna assume. Like this. Yes. This is a track 1. I can call T1. This is a track 2. And assuming that this is my track 3. I have a total 3 tracks. Fine. So, to distinguish track 1 with the track 2, there is a small gap was exist between these 2 tracks. This is that small gap. This small gap what I can call is inter-track gap. This is what I can call is inter-track gap. It is very useful for me in order to read or write information from a specific track. So then these gaps are very helpful for me, because sometimes there is errors are exist in your disk system. Due to that, your head may not be placed correct position of your surface of a disk. In order to overcome such type of difficulties, what I have to do is, I have to go and place some gaps between 2 tracks. So this particular one, what we can call is inter-track gap. And similarly, here this is another gap between a track 2 and a track 3. Fine. And we know that each and every track can be divided into number of sectors. For example, it is like this. It is like this. It is like this. So this is one track, this is another track, and this is another track. Right? So if you observing or not, guys, here there is a small gap was exist between sectors. So here this is a gap, and here it is a gap, and here it is a gap. This particular gap, what I can call is intersector gap. These are two, intersector gap as well as inter-track gap, was very helpful to us whenever some malfunctioning was going on in your disk systems. To overcome such difficulties, these gaps are very important to us. So one type of gap what we can call is inter-track gap. What this is? To distinguish two successive or consecutive tracks, there was a small gap was exist between those two tracks, that is called inter-track gap. Similarly, to distinguish two consecutive sectors, there is a small gap was exist which we can call as intersector gap. These are two are very important. And next, the data bits are stored serially on each track. So how we are storing our data? The data was stored on tracks in the fashion of serial. Serially, the data was stored on the surface of your disk. Each sector contains 512 bytes. Generally, each sector how many? So this is, you can assume one sector, it can hold total 512 bytes. Nowadays, each sector contains more than this number also. So some value, that is the number of bytes we can store on each and every sector. In a maximum occasions, we can say that was a 512 bytes. But nowadays, due to advancement of our technology, what happens is each and every sector of magnetic disk can hold linked it to 512 bytes. The value may be greater than 512 bytes. So that you have to keep in your mind. An unformatted disk has no information on its track. So what this is? If you are not formatting this particular disk, then such disk we can call as unformatted disk. Once your disk was not formatted, then no information was present on the tracks. That's it. You have to remember that. The formatting process divides disk physically into tracks and sectors. So what we are doing in our formatting of a disk system or formatting of a disk, that means simply dividing of your surface of a disk into number of tracks. Later it can be divided into number of sectors. This particular process what we can call is formatting. That you have to remember. Each track has the same number of sectors, so all tracks have the same storage capacity. That means I can say that like this: the number of tracks may exist on my disk system is somewhere. Each and every track can hold up some 2 kilobytes of information. That means the 2 kilobytes of information not only present on track number 1. If I go for any track out of n number of tracks which are present on the surface of my disk, each one can hold only 2 kilobytes of information. So that is the meaning of this. Each track has the same number of sectors, so all tracks have the same storage capacity. The track may exist inner, or it may exist outer, or it may exist in between. Irrespective of that, each and every track can hold equal amount of information. That you have to remember. So it is possible to increase the storage density by placing more sectors on outer tracks which have longer circumference. What the meaning of this? See here, friends. This is my disk. Let you imagine this is track 1, track 2 and track 3. There are 3 tracks. So what we are saying in the first point is the amount of information I can store in this track is equal to the information I can store in this track is equal to the information I can store in this track. So there is no change in the amount of information was stored in track. If you observe in this track, I think the space that was available in inner track is less compared to the space that was available in outer track. It is somewhat not advantage to us. We are not utilizing this space effectively. If I want to utilize effectively the outer spaces, then what I have to do is, instead of assigning less number of sectors like inner tracks, I'll go and arrange more number of sectors in outer tracks. For example, inner track I can incorporate like this. Just I incorporate 5 sectors. Sector 1, Sector 2, Sector 3 and Sector 4. Sorry, 4 sectors. If I come into the next, I can go and increase its count. It may be like this. It may be like this. It is S1, S2, S3, S4, S5, S6, S7. If I go for the outer one, I can go and incorporate more and more number of sectors like this. Then automatically the information I can store on this disk can be increased. For example, here it is S1, S2, S3, S4, S5, S6, S7, S8, S9, S10, S11, S12. So in case of previous case, in the previous step what I can say is, each track has the same number of sectors. So all tracks have the same storage capacity. It is not that much good for me because in outer tracks I have much more space compared to inner tracks. Then what I have to do is, in order to increase the storage capacity of my disk, I have to go and increase the number of sectors if I am moving from inner track to outer track. So that's what I am using next. It is possible to increase the storage density by placing more sectors on outer tracks which have longer circumference. That means I have a longer space. So that I have to go and incorporate more number of sectors. Due to that, the density, the storage capacity of my disk can be increases. So this type of technique right now we are using in our disk systems. You have to remember that. Next, there are 2 components involved in a time delay between a receiving an address and the beginning of actual data transfer. So here important thing is, we are considering 2 important components while we are calculating our time periods. So how much time our system will take to read or write an information to or from a magnetic disk. In that case, here we are considering 2 important time components. So that involves time delay between the receiving an address. That means like your semiconductor memories, your CPU can want to have information from storage elements. What it has to do is it has to generate an address. So it is receiving an address and beginning of the actual data transfer. So at what instant actual data transfer starts. So for that case, I'll consider 2 timing components. One is a seek time. What is seek time? It is the time period to move the read-write head onto proper track. See here friends, again, this is my disk, this is my disk. So somewhere else here I have a head mechanism. This head right now it can be placed on this. So this is here I have head. It can be placed on this outer track. So what my seek time? In the next time incident, I would like to receive the information from. So this particular track. And here especially I would like to read the information from this corresponding sector. I would like to read my information from this corresponding sector. As of now, my head is present over this track. So now, based on this simple analysis, here what meaning of seek time? Seek time, it is a time period to move this read-write head to proper track. That means the sector which is considered as a destination for you, we have to go and verify that sector was present on which track. So your head was present some other track on the surface of a disk. How much time your disk system will take to move the head to the corresponding track. That means I want to read an information from this corresponding sector, so that this head, now I was moving from this track to this track. I have to move up to this, right? Up to this. To move my head from this to this, how much time your disk system will took? That time here we consider as seek time. That time here we can consider as seek time. So it is the time period to move read write head to the proper track. I am not talking about proper sector. It was moving to proper track. So if I move my head to this proper track, I am not going to access my information from this corresponding sector. I would like to access my information from this sector itself. So if I move my head from this point to this point, that is not sufficient for me. So the time it takes to move your head from current position to required track, that we consider as a seek time. I have to go and consider second time component, that was I can call as a rotational latency or rotational delay. So before discussing this, here I would like to add one more point. This depends on initial position of head relative to track specified in the address. Yes, it is absolutely. For example, if I want to move from head this position to this position, your disk system will take some 3 seconds. To move this head from this, if my example, my destination was present on this corresponding track, then to move head from this to this track, it not takes 3 seconds, it takes only some 2 seconds like this. So that here we clearly says the seek time depends on the initial position of head relative to the track specified in the address. So based on your destination address. So based on that, here this seek time depends. You remember that. Next, what the next one is a rotational latency, or sometimes it is also called as a rotational delay. It is the amount of time that elapses after the head is positioned over the correct track until the starting position of the addressed sector passes under the read write head. Yes, it is absolutely friends. See here. For example, my image, I would like to access an information from this corresponding sector, right? Right now my head exists on this. So in order to move my head from this position to this position, it takes a certain amount of time. The time I can call as a seek time. Now what I have to do, if I want to read an information from this corresponding sector, I have to rotate this disk. Then this disk simply moving like this. It is moving like this in this direction. So after certain amount of time, this sector comes beneath of this head. After certain amount of time, this sector exists here itself. So how much time it takes to move this sector from this to this? Actually the sector was not moving, this your disk was moving. So in that case, how much time it takes to move this sector from this point to this point, that amount of time we consider as a rotational latency or a rotational delay. So here I clearly mentioned it is the amount of time that elapses after the head is positioned over the correct track until the starting position of the addressed sector passes under the read write head itself. So this is what's the meaning of a rotational latency. Next, the sum of seek time and rotational latency is called as access time. This is important to us. The combination of seek time and rotational latency or rotational delay, what we can call is access time. So here I am talking about 3 times. One is a seek time, second one is a rotational delay or rotational latency, and third one is access time. So these time periods are very, very important for disk systems, that you have to remember, friends. So this is about our secondary storage devices, that is a magnetic hard disk. Thank you for patient listening. In the next class, I am going to discuss another storage element, secondary storage element, that is a floppy disk as well as a CDs or DVDs, that I was discuss in the next class. So thank you for patient listening. Thank you very much.